8.5, which states that if in a quadrilateral each pair of opposite angles is equal, then it is a parallelogram. Now observe the statements of theorem 8.4 and 8.5. 8.4 says that in a parallelogram, opposite angles are equal. So here, it was given to us that ABCD is a parallelogram, and we had to prove that angle A is equal to angle C and angle B is equal to angle D. Now look at the statement of theorem 8.5. It says if in a quadrilateral each pair of opposite angles is equal, then it is a parallelogram. Now observe that the conclusion of theorem 8.4 became the given of theorem 8.5. So it says each pair of opposite angles is equal. And the given of theorem 8.4 became the conclusion of theorem 8.5. So we conclude that it is a parallelogram here. So it is given that ABCD is a quadrilateral, okay, and the opposite angles are equal. We will prove that the quadrilateral is a parallelogram. Now let us just recall theorem 6.5 from chapter number 6, which says if a transversal intersects two lines such that the pair of interior angles on the same side of the transversal is supplementary, then the two lines are parallel. So if we have interior angles on the same side of transversal, that means this angle and this angle, and their addition is 180, that means they are supplementary, then we can say that AB is parallel to CD. We are going to use this result to prove this theorem. Now coming to the theorem. Theorem 8.5. If in a quadrilateral, each pair of opposite angles is equal, then it is a parallelogram. So it's given that ABCD is a quadrilateral and angle A is equal to angle C. So you can see here angle A is equal to angle C and angle B is equal to angle D. So angle B is equal to angle D. We have to prove that this quadrilateral ABCD is a parallelogram. Now, let's understand the proof. So we will use the angle sum property of a quadrilateral. The angle sum property of a quadrilateral says that the sum of all the angles of any quadrilateral is 360 degree. So we will say angle A plus angle B plus angle C plus angle D is equal to 360 degree. Now, as it is given that angle A is equal to angle C and angle B is equal to angle D, we can replace C and D with A and B. So we will have 2 angle A plus 2 angle B is equal to 360 degree. 2 is a common factor which can be taken out. So 2 bracket angle A plus angle B will be equal to 360 degree. And now taking 2 to the right hand side, we get angle A plus angle B equal to 360 degree upon 2, which gives us 180 degree. Let us take that as result 1. Now look at angle A and angle B here. Angle A and angle B form interior angles on the same side of transversal if we consider lines AD and BC and AB as their transversal. So if we consider AD and BC and AB as their transversal here, you can see that these two angles A and B are interior angles on the same side of transversal. And as angle A plus B is equal to 180 degree from result 1, we can say that AD is parallel to BC. AD is parallel to BC. a pair of interior angles on the same side of transversal is supplementary, therefore the sides are parallel. Similarly, we can also prove that angle A plus angle D is equal to 180 degree. So we can prove angle A and angle D are supplementary, and they also form interior angles on the same side of transversal if we consider lines AB and DC. So if you consider AB and DC and AD as the transversal, AD is the transversal, then angle A and angle D are interior angles on the same side of transversal. And since we can also prove them that they are 180 degree, we can say that AB is parallel to DC. Now, as AB is parallel to CD and BC is parallel to AD, we can say that ABCD is a parallelogram.